Okay, let's go through this question. We have a toy rocket launched from the ground with a flight path that resembles a quadratic curve with a maximum point, so means it's a set phase. Then its height, h, above the ground is given to be as such, right? So we are given the equation to be h equal to bt minus at squared. So they ask us that the rocket will reach a maximum height of 9 meters before descending to hit the ground 6 seconds after launching. Show that A is equal to 1 and B is equal to 6. Okay, so how do we actually do this question? Very simple. First, you sketch a graph. The y-axis is h, the x-axis is t. So of course, at the start, right, t equal to 0, your h is equal to 0. Then you will reach a maximum height, which I don't know what time, but it's 9, maximum height is 9 meters, but you will hit the ground at 6 seconds. How do I actually show that A is equal to 1, B equal to 6? Very simple. Okay, we assume no air resistance, no nothing, right? So means that since you hit the ground at 6 seconds, means that you will reach the maximum height at 3 seconds. So meaning that, I already got one coordinate already. So the first coordinate, x coordinate is 3, then the y coordinate is 9, so just need to sub in. So for example, right, h is equal to bt minus at squared. So of course the t is 3, and this is 3 squared, right? And then the h is 9. So this will actually give you 9 equal to 3b minus 9a. So that's the first equation. So I just simplify first. So I divide by 3 throughout. So this will give you 3 equal to b minus 3a. So this is my first equation. Of course, I need my second equation. That's where I need to use the 6 seconds. So means because at 6 seconds you're at the ground already. So means that the height is 0. So at this point is 6, 0. So just need to sub in. So for example, right, h equal to bt minus at squared. So this is your 0, and this one is your 6 squared. So this will give you 0 equal to 6b minus 36a. Yeah, that's how we actually do this. And of course, I divide by 6 throughout. So divide by 6 is still 0. b minus 6 is 6a. So this is the second equation. So of course, you can just simply use first equation minus second equation. So this will actually give you, for example, b minus 3a minus b minus 6a, and 3 minus 0 is 3. So this will give you minus 3a plus 6a. So this is 3. 3a is equal to 3. A is equal to 1. So this given, I showed this already. Okay. So of course with this, I need to find my b. So b at 0, I sub in a equal to 1 into equation number 2. So b is equal to b minus 6. 6 times 1 is 6. So b is equal to 6. Yeah, so shown already. So that is the first part to this question. You simply just need to look at the maximum point. A bit of physics to be frank. So you look at the maximum point. Because you reach the ground 6 seconds, means that you have maximum height at about 3 seconds. Okay, then let's talk about the part B as well. Using the values, right, of A and B, find the amount of time that the rocket is above the height of 0.59 meter. So, okay, let me just sketch this again. So this is the graph H, T, right? Set phase. So this one maximum height, 6 seconds here. So, okay, 0.5, okay, this is 9 meter. So 0.59 meter is here. Around here. So means they want to find what is the time duration around here. So they want this amount of time duration. So for example, it's so I want to know what's this time duration. Okay, how do I actually do this? Very simple as well. So first, right, you just need to equate the equation to be as such. So h is equal to b, right? B is 6t minus 1t squared. So it's just t squared. So because you want to be above 0.59, so means you just simply put like that. 6t minus t squared is greater than 0.59. Then you move everything on the left hand side. So minus t squared plus 6t minus 0.59 is more than 0. So of course, the next thing is to actually times -1 throughout. So it's t squared minus 6t plus 0.59. Then you flip the sign, right, less than 0. Okay, with this, maybe I do a bit of conversion because I want to solve the quadratic thingy. So first is t square. Okay, maybe I convert this to 59 over 100 first. Then you times 100 throughout because I want to make it into a very proper formula. So t square minus 6t plus 59 over 100 less than 0. So I times 100 throughout. So it's 100 t square minus 600 t plus 59 less than 0. So that is the thing. Then the next part I will say, okay, maybe not. Maybe I just keep it as such because I think it's quite complicated. Okay, with these, you solve the t first, meaning negative b plus minus square root b squared minus 4ac over 2a. So let's write down plus minus square root b squared. So b squared is 36. I'll just write first over 2a. So this is negative b is 6 plus minus square root 36 minus 4ac over 2a. So 2a is 2 times 1. Just 2. So okay, let me just do a calculation. Okay, so inside the square root is like that. So it's square root 33 16 over 25 over 2. So okay, make it into 841. Okay, square root 841. Let's see. Okay, I think yeah, it's a very nice number. So 6 plus minus square root 841 over 25. Double check. Yeah, correct. Over 2. So this will give you square root 841 divided by 25. So it's about 6 plus minus 5 4 over 5 over 2. Okay, let's continue on. So it's 6 plus 4 5 divided by 2. So this is about 5.9 or 6 minus 5 4 5 divided by 2. So this is about 0.1. So it's 0.1. Okay, so that is the solving part, right? So I solve for t lah. So means for example, I go back to the equation that I format. So this one, hopefully I never do it, make any careless mistake. So t square minus 60 plus, okay, 6t plus 59 over 100 less than 0. So because I solve already, means that I simply just put it down. So t minus 5.9 t minus 0.1 less than 0. Okay, then you draw the happy face. So it's like that. So means it's from here to here because it's less than 0. So meaning this is 0.1 second. This is about 5.9 second. So the time that we are looking at, right, is 0.1 all the way to 5.9. So of course they want the amount of time, right? So you simply just use 5.9 second minus 0.1. So it's about 5.8 second. So that is how we do the part 2. Okay, then let's talk about part 3 as well. Okay, part 3, they say beside vertical motion, the rocket also travel an average horizontal distance of 1.5 meter per second. Find the distance between where the rocket hits the ground and the point at which it's launched. Okay, for example, for this question, so it's actually talking about this. For example, it's like that. So this is the land. Then you launch the thing. So you launch the things like that. So they want to find what is this distance. Okay, so based on the previous answer, because the previous or no previous answer, okay, because they this rocket actually make travel not say travel the journey the time for the journey, right, time for whole journey is about 6 seconds. So means that okay, at this point time is equal to 0. At this point, if I hit the ground, right, it's time equal to 6 seconds. So how do I actually determine this amount of distance? Very simple, because they already tell us, right, that okay, I refer to the question. They say that average horizontal distance of 1.5 meter per second means that I travel 6 seconds, right? So means it's 1.5 multiplied by 6. So this is about 9 meters. So let me just double check. sorry, not 9 meter. 1.5 times 6. 9 meter, correct. So the answer for the horizontal distance is about 9 meter. So that is how we actually do this question.